In the 1930s, Ralph Proctor developed a test that illustrates the change in density that occurs when soil is compacted at different moisture contents. For fine-grained soils, or mixtures of fine and coarse soils, the moisture-dry density relationship typically yields an asymmetrical bell-shaped curve. The flatter the curve, the greater the amount of silt and clay present in the soil. Conversely, a peaked curve indicates a smaller proportion of silts and clays. You'll note I have plotted the dry density rather than the bulk density along the vertical axis. Before we discuss why we use dry density, please note that both curves have a well-defined peak or maximum dry density, and this corresponds to a moisture content known as the optimum moisture content. It is these values that the contractor aims to achieve when compacting the soil on site, but more about this later. Let's firstly discuss why dry density rather than bulk density is used when specifying compaction targets. We can see from the definition of bulk density that the mass component can be divided into two parts, the mass of solids and the mass of water. Then, for a given volume of soil, the mass of solids remains constant, whereas the mass of water can vary on any given day depending on the weather. Therefore, specifying compaction on the basis of dry density allows us to compare increases in density as a result of compaction. A similar comparison is not possible using the bulk density, as changes may be due to increases in the moisture content rather than densification due to compaction. It is important here to remember that specifying or measuring dry density as an indicator of the degree of compaction does not mean that the soil is dry. We can see this by rearranging the bulk density relationship and noting that the moisture content is defined as the mass of water over the mass of solids. From this, we get a substitution for the mass of water in terms of the mass of solids in the bulk density formula. Then, taking the mass of solids to one side in the numerator and dividing it by the volume gives us the dry density of the soil at this particular moisture content.